Okay, so we'll start. See, last class we covered ACL, right? Access control list. We understood there are two types of ACLs. One is standard, and then the other one is extended. Okay, so standard is very basic. Extended, you have more flexibility in blocking the traffic. Right, I demonstrated that also. Right, I know I have not added the commands yet. I'm kind of little busy with my everyday schedule. Okay, back-to-back classes, and I'm very busy. So definitely, in the weekend, maybe by today or tomorrow, I'll add the commands. So please do practice all the concepts, right? I think almost 50% of the concepts, the recordings are already, the commands are already uploaded. For the commands for the last few classes, I'll definitely upload it in today or by tomorrow. Okay, so please practice it. Okay, so today I'm going to discuss about one of the very important and a very interesting topic, which is network address translation. Okay, see, right now, if you guys are accessing internet, okay, which you guys are doing, right? You're joining my class means you're accessing internet. So if you're accessing internet, this concept is happening. Network address translation is happening because NAT have to happen for anyone to access internet. It's an awesome topic, right? If you ask me, which is the favorite topic for me in networking, right? I would say that subnetting is first, okay, because I love mathematics and subnetting is my favorite. So next to subnetting, if you ask me which is a favorite topic in networking, I would say definitely network address translation, right? So this is such a nice topic. I really wanted to give you guys a very good understanding about network address translation. Okay, so we're gonna discuss this for maybe maximum 1 hour, next 1 hour, and then we'll be covering the firewall. So I can give you a why NAT is required, what is NAT, right? What is public IP, private IP? You'll be understanding those things in this session. There are many advanced NAT topics also, which we cannot cover in this session, but I'll give you a very good understanding about what is network address translation. Okay, see, if you take the total number of IP addresses, guys, starting from 0.0.0.0 till 255.255.255.255. Okay, so if you take this range, so totally there are 4.29 billion, or maybe if you want to write in crores, it's 429 crore IP addresses. Okay, or it's 4.29 billion. So these many IP addresses we have. Okay. And I already told you in previous class itself, right? These classes are classified in 5 different classes: class A, B, C, D, and E. Okay, class D and E, we cannot use those IP addresses for any machines, right? Maybe if you have a PC and if you want to assign an IP address to the PC, you can choose only from class A, B, C. You cannot take it from class D, or you cannot take it from class E. Okay, so in that case, right? So if you the total number of IP addresses that is possible to give to the routers, PCs, switches, those that limitation is only with class A and B, right? So if you yeah, so what I'm trying to say is the total number of class A, right? From class A, if you count class C, the last IP address of class A is 223.255.255.255. So these are the this is the range of IP addresses which we can use to actually set up a network, right? You cannot use class D or class E to set up a network, right? If you want to have a network like PCs, routers, servers and all, you can choose only IP address in this range. Like D and E, I told you already. D is used for multicasting, and E, there is no idea why E is actually used. But anyway, that is wasted. Okay, let's understand this way right now. Okay, so if you count class A, B, C, and L, right, those are the addresses that is usable, right? So those usable addresses, if you calculate, they come close to 375 crore IP addresses, right? Or in other words, it's 3.75 billion IP addresses. Okay, so we have only 375 crore IP addresses, but the total number of devices that we have right now in the world, okay, just assume how many number of devices we have. We have more than 2,000 crore plus 2,000 crore plus devices we have. Okay, so if you take your laptop, if you take your phone, that comes inside this 2,000 crore devices. So totally the total number of devices are 2,000 crore, right? But the total number of IP addresses we have is 375 crore only. Okay, and this is gonna keep increasing, right? I don't know, right? For last 2 years, I've been saying the same number, 2,000 crore plus, but I think now it has reached even more, right? I think maybe I can even say like 2,005 crore, 2,500 crore plus devices are there. Not sure, but definitely, I know 2 years back when there was a survey taken, and the survey says that 2,000 crore plus devices that was taken 2 years back. Maybe now, of course, devices count has increased, and this count is going to keep increasing. But the number of IP addresses is always fixed, right? Because why? because this is the total range, right? So if this is the total range, this is the fixed number of IP addresses we have. Okay, so now the problem is, right, this count is keep increasing, right? Maybe if you see in next 10 years, this 2000 crore number of devices we have right now in the world will go to 5000 crore devices. Who knows? Okay, it can even reach, like, because nowadays every appliance that we buy, right? It can be a TV or a washing machine or an AC, whatever it is, it has got network support. Okay, so the number of internet related devices will keep increasing. Okay, so this count will keep increase definitely even in future, but this number is going to be always constant. So now how do we manage situation? Right? If you take the present moment, assume that 2000 crore devices we have, we'll take this count itself. Right? Of course, it is going to be more than that, but definitely more than that. But we'll take example as 2000 crore devices. But how many IPs we have? 375 crore IP address only we have. Okay, so 375 crore IP address in the sense already there is a shortage. You can understand, no? Now itself the ratio is somewhere around 5:1, right? Maybe for 5 devices we can give only one IP. That is the ratio, which means out of 5 devices only one device can take an IP address. The other 4 devices are left out without IP address. So one out of 5 can take an IP. 4 out of 5 cannot have an IP address. That is what the number of IP. This is the number of devices. This is, right. You see, we don't have sufficient IP to give IP to all the devices in the world, right? We can give 1 out of 5. If you choose 5 devices, only one device we can give IP address. So that is the count right now here. But we have to provide internet access to all the devices, right? So if these 2000 crore devices are in the world, every device needs internet access, every device needs network access, but we have only limited number of IP addresses. So then how do we manage the situation? See, there is a long-term solution. This long-term solution is IPv6. Right, we are not discussing that in the course, right? But it's a long-time solution or long-term solution, I can say. IPv6 is not very deeply implemented right now. IPv6, of course, we have IPv6 network set up in many places, but still IPv4 is dominating. Okay, IPv4. What is IPv4? This address, right? 0.0.0.0.255.255.255.255. This is an IPv4 address. Right? IPv6 address, it's larger, it's even bigger. IPv6 is 32 bits. Yeah. So you have 2 power 32 IP addresses. That is what this 429 core IP addresses is. But if you take IPv6, it is 128-bit address. It's a very big address, right? This IPv6 address is gonna look very big than IPv4. So IPv6 is going to be the permanent solution, right? But people right now during the migration from IPv4 to IPv6, right, this portion will take a lot of time, right? Maybe it may take, it started already, maybe, or I can say 20 years back it started, but still the migration is going on. Maybe it may even take some 30 more years, 30 to 40 plus years to completely migrate our systems to IPv6, right? So now we are using IPv4. I use IPv4 in my network, in my home. You guys are using IP4 in your home. You guys are using IP4 in your office. IP4 is dominating. 99% of the network are completely in IPv4, right? This is very less, right? The remaining percent. So the migration will take some time, right? It already started. The migration is slow, right? But in future, maybe in 30, 40 years, we can expect everyone migrating from IP4 to IPv6. But during that time, what is the solution? Okay. So the permanent solution is IPv6, but the intermediate solution is network address translation, right? So understand the problem first. The problem is we don't have enough IP addresses. IP address shortage is there. Then IPv4 has got many, IPv6 has got many IP addresses. But to migrate from IPv4 to IPv6, it's gonna take many years. So during that time, we have an intermediate solution called network address translation. Okay, so now let's try to understand what is network address translation. It's very simple and it's very interesting also. Okay, so I told you, class A, B, C, these are only counted, and because only these IP addresses we can use in a network, they have totally 375 crore IP addresses. Okay, in this 375 crore IP addresses, it has been categorized. Right? If you take class A, B, and C, totally 375 crore IP, it has been categorized in 3 categories. I can say simply. One is, right, you can say private IP. Right? The other one is public IP. Okay, private IP, public IP, and also we have some reserved IP addresses. Reserved IP. There are IPs that cannot be used in a network. Even in this range also, there are some reserved IP addresses which we cannot use. Okay, so now I'll give you the private IP address range. Okay, every class has got their own private IP. And basically, private IP means you can understand they are free to use. Okay, any organization can use private IP address. In their organization, they can use it for free. Okay, so we'll have class A. In class A, the private IP address is 10.0.0.0/8. Okay, this is the class A private address. Now class B. So in class B, it is like 172.16.0.0/16, and then 17.0.0/16. Likewise, it goes to 172.31.0.0/16. Okay, finally we have class C, right, which is 192.168.0.0/24. From there, now 192.168, 1.0/24, 2.0/24, again 255.0/24. So these are the private IP addresses we have in class C. So here, and I can say some reserved IP addresses. Reserved IP addresses, I can say it like no 0.0.0.0/8. This is reserved. You cannot use it in any network. You cannot go and set up a network with this series of IP addresses. Okay, this is reserved. And also, what else is reserved? I can say 120 7.0.0.0/8 is reserved. And then 169.254.0.0/8 is reserved. And I can say, sorry, not /8, it's /16. Okay, and I can say few more IP addresses. I'm not listing every IP because there are no a few chunk of IP addresses that is reserved. Yeah, so it has got even more IP addresses, which I'm not talking over here. Yeah, so there are few reserved IP addresses, right? On all the remaining IPs. So all the remaining IPs you can consider like public IP addresses. So which means to take the total 375 crore IP addresses, 1% is here. 1% they have been declared as private. Maybe 1 to 2% I can say. 2% are reserved. Okay, so 1% private, 2% reserved. The remaining 97% of the IP addresses. Okay, the huge of 97% of IP addresses or public IP. Now you can calculate, 370 crore means how much is 97%, how much is 1%, how much is 2%. You can calculate yourself. So 97% of the IP addresses, all the remaining IP addresses are basically public IP addresses. We cannot write them because it's a huge count. You can understand, right? If you minus private and reserved, then remaining IP addresses will be public, right? And what is the range, please? What is the range of yeah, what is the range? This is the range of class A, B, C. This is the range. In this range only you have 375 crore. In the 375 crore, private, public, and then reserved is there. Okay. Now we don't have to really worry about reserve because that is reserve for some reason. Let's ignore that. That is not really important for us. We're gonna concentrate only on the public IP address and maybe private IP address. Got it? Okay. So now let's understand this variance. Okay. So now what is the fact? The fact is we have shortage of IP address. The IP address is shortage. We all understand this. There is a shortage of IP address. So now since there is a shortage of IP address, we cannot allot IP address to every device uniquely. Yeah, so shortage means you cannot give every IP one device. You cannot give every device one IP, right? So there is a shortage. So what we have to do is, the idea is very simple. Okay? Any organization, it can be your college, it can be your home network, it can be your office network, it can be any cafe, airport, railways, whatever network let it be, guys. Now they can set up their network with private IPs. Here, let me take a different slide and just explain this. Okay, now if you see the IP address at your home, right? Maybe I just open command prompt, right? And I'll give IP config. And the moment I see IP config, I can see that my IP address is 192.168.29.226. Now all of you guys, when you try, maybe you can try it now or you can try it later also. Okay, when you give this IP config command, you will be able to see the IP address of your device, and the IP address will definitely be in private series under, right? Okay, so why it is for me, why it is private C? Yeah, why it is C? Because it is home network, right? So home networks are small. So for home networks, generally we go for private C. Maybe some colleges and all, right? So they go for private V, and a very big multinational companies, a very big network and all, they go for private A. So we know why A, B, C is there. Depending on the size of the organization, you can use A, B, or C. So home uses small, so class C. Colleges, universities, mid-scale businesses, they go for B, and huge businesses they go for A. Okay, that is why I'm right now I'm at, and this is the series of IP. So this is the private IP. So which means anyone who wanted to, yeah, thank you. anyone who want to set up a network, or maybe it can be a home network or it can be an office network, whatever it is, they can set it up with private IP addresses. Okay, so now assume that there is a company. You have to understand this concept very well, guys, because if you're not getting it, then you will not understand the purpose, or you will not enjoy the concept. So assume that there is a company here. So company A, they have got, assume that the company A, the number of devices in company is, let's say, assume 100 pieces. And not a very big company, but some kind of a mid-size company, let's say. Okay, so 100 pieces they have got. So now they wanted to have a network setup for them. Okay, so what they decided is maybe they are having a few switches with them. Right, assume this is a switch. Okay, and the switch is connected to the router. Okay, and then you have PCs over here. You have PCs over here, and we have some kind of a no. Assume that there is a server. Maybe it could be a web server or something like that. Okay, so they can also have a printer. Okay, so just to a network printer, a common network printer, a printer. Okay, so yes, so these are the, I think this is a small office network that we have got. Now, since they want to have a network for themselves, right? Since they want to have a network for themselves, this has been declared, right? Who declared it basically, right? Who decides all these things? Who decides this is a private IP, public IP now? See, basically, there are many organizations which is controlling internet, right? In that, the IP addresses of internet are controlled by one organization called IANA. Okay, IANA, Internet Assigned Number Authority. So he's a person who decides the ranges of IP addresses, all those things. So he's a person who decided the range of private IP, public IP, reserved, all those things. Okay, so he says that any organization who want to have a network for themselves, they can use these addresses for free, right? They are for free. So there is no need to get permission from any government or any organization to use these IP addresses in your network. Got it? Okay, so now here, since this is company A, they have got 100 PCs, they want to do some small network, they need to upload some files to the server, they want to print something, they want to do exchange the messages, they want to do some file sharing between them. So they want a network, everyone needs a network, right? So they create a network for themselves, and now they have a web server inside their organization. It can be a web server, it can be a file server also, so that people can upload files and download it later. Okay. Now, what we have to understand is the company A decided to use this network, right? So since it's a small network, they decide to go with 192.168.1.0, right? Our traditional network. So they decide to go with this class C network because 100 PCs, this class C is sufficient, right? Okay. So now let's try to understand this way. So this guy, right, 192.168.1 PS and 1.2, 1.3, 1.4, right? Assume this guy is 1.100, web server 1.100, and this guy printer 1.101. Okay, this is a network they have created. Now, they can do the communication inside them. What I'm trying to say is they can do the communication between them, which means the local area network is possible. You can talk to this guy, you can talk to this guy, you can talk to this guy. So inside your organization, you can do all sort of communication, right? So this is what we call as LAN, local area network. Or even some people, they refer this as intranet. Intranet means you are talking inside your campus. You are talking inside your organization, right? You have network servers, everything inside your network. You are talking inside your network itself. Okay. So now let's go to company. Assume that there are many companies in the world, right? Assume there is one more company called Company B. Okay, let me just take it this side. Okay, so we'll take company company B. Company B is also kind of having, they have some, they have, let's assume that they have 150 pieces with them, 150 pieces with them. And they also believe that, 150 PC is not a very big thing, but again, they can accommodate with a classy network. So they also decided, see, since this count is free, guys, since all these addresses that are wrote in green color, these are free IP addresses, which is a private IP. It's completely the organization's choice to choose what address. They can use 10 series, they can use 176 series, or they can also use 192.168 series, depending on the size and depending on how they can choose whatever they want. Now assume that this company B also, they also decided to use 192.168.1.0 itself. They also decided to use 192.168.1.0/24 network. Okay. So here we have the same example. I don't have space, right? Let me just move this above. Okay, same thing. Right? They have a switch with them. Okay, they have a router connected. They have PCs connected to them, and they have some kind of a server here. and they have some printers. Kind of same, right? Because all organizations, they have similar setup, right? Printer, web servers, email servers, file servers, and all. Okay, so let's take like this. So now I'm gonna take. I'm just gonna go in. Give this guy an IP address. So I think this guy is 1.1 because they decided to use 1.0. It's 1.1, 1.2, 1.2, 1.4, 1.151, 1.152. Okay, so like this. Okay. Now, again, company B, they set up a LAN network for their communication, right? Now, this PC can upload some files into the server, and this guy can access it, and he can upload something, he can access it. Now, this guy can go and commonly use this common printer. Yeah, everything is fine, everything is good. So now, both organizations, they have set up their LAN network, right? So they have set up the LAN network in the sense they can talk to the devices inside their organization. Very good. But we all know that this PC needs something. This PC might have something or might need something. I mean by might need something, but that is not available in the local network, right? That might be available in someone else's network. Yeah. So let's take this as an example, right? Company A, company B got it, right? Assume company. Let's take Google as an example. Assume Google is there. Yeah, I'll write it over here. This is Google's office. Okay, or you can say Google's data center, something like that. Okay, now you have company A, company B, everything is good. Let's go with this side, you should better understand it. Okay, so Google Office is there, and Google Office will also have a switch, and they'll have a server. Again, this is what the Google server that we wanted to access, right? The traditional Google.com server. Okay, the server inside their office, they have a Google server, and they have their own, they have some employees working in the company. So their PC it is, you have one more PC here, right? And this Google Office switch is also connected to their own router. Okay, so now assume that they even wanted to have a network setup, right? So again, they decided to use some IP address like this. Assume that they decided to use some 10 series IP, 10.0.0.0, 10.0.0.0/8. So since Google Office is little bigger, they want to go with class A network. So this is the thing that this is a private class A, right? So free. Even Google can use. Google should use free IP address only to set up their own local setup. I mean the LAN setup for them. Okay, so now you assume that this guy is 10.0.0.1, and this guy is 10.0.0.2, and this guy is 10.0.0.3. This guy is 10.0.0.4. Right? So we have like this. Now, again, what is happening here, guys? Again, the LAN is done. Here also, the local area network is done. Now, if this PC wanted to access Google, he can access, right? Because they are in the LAN. Assume this is a google.com server, guys. But google.com server is reachable only by whom? Only by this guy who's inside their organization, right? There is a PC inside their organization. Inside, just assume inside Google Office, there is a PC. That PC can access Google server, and he can do some searches and all. Everything is possible. Again, this is also what this is also LAN. Now, if you see this example, how many LANs we have? One LAN in company A, one LAN in company B, and one LAN in Google Office, right? Like this, if you take, just think about the whole world, guys. Just think about the whole world right now, right? How many LANs are there? How many local area networks are there? Every organization, they have their own network. Every colleges, they have their own network. Every schools, they have their own. Every home network, they have their own network, right? So here we have billions of LANs, right? So you are right now in your home network, right? You are in your home network. You have your laptop connected to the home network. You have your phone connected to the home network. You might have your father or brother's phone connected to the home network. You guys are again in a LAN, right? So if all of you guys are connected the same way, what I mean by how many devices are connected in your home network right now? In your home router, home Wi-Fi, home Wi-Fi router, all you guys are still in the LAN, right? You can talk to each devices directly. So there are billions of LANs we have. Right? Just imagine how big the world is, and we have billions of local area networks. Okay. Now, what LAN basically does is, right, you can talk between the devices in your network. Okay. So this guy can talk to this guy. This guy can talk to this guy. This guy can talk to this guy. Or this guy can talk to this guy. This guy can talk to this guy. These things are possible. But the reality is, the world needs what? The world needs WAN, wide area network. Which means what is it? Right? There is a user here. Right? There is a user in this office wanted to reach google.com server, okay, which is in the LAN of Google Office. Google Office, they have got their own local area network. That is where you have the google.com server. Now, this user in company A wanted to access the google.com server that is in Google's Office LAN. Okay. So now this is what we need, because all the time you cannot just go and see in your network. Sometimes you need to go out of your network, and something that you need, right? That something will be available in someone else's LAN network. You got the idea? Someone else LAN network. For example, here, Google Office, they have their own LAN network. They have their own google.com server, which is required for all of us. Now, I go to Google. See, I'll take the browser. Okay. So I go to Google. Now, where I'm accessing this Google is where actually the Google server is physically located where? It is physically located in Google Office in their LAN network. You got the idea? Okay. So now, yeah. So what I'm trying to say is, guys, we need some time, or not some time, most of the time, we need to go out of our network and reach someone else's network, someone else server to get some information. Okay, so that is what, this LAN need to connect with this LAN. This LAN need to connect with this LAN, right? And when all the LANs are connected, right? I told how many LANs we have. We have billions of LANs, right? Connecting all the billions of LANs is what we call it as what? Wide area network, right? WAN, right? Connecting multiple LANs becomes WAN, or connecting multiple LANs is what, in other words, you can call it as what? Internet. What is internet? Internet is nothing but connecting all the local area networks, so you get internet. Okay. So now the difficulty here, let's understand the difficulty here. Okay, who's gonna connect us? Which device is gonna connect us? Which company is gonna connect? You have your company A, company B is here, Google Office is here, but someone need to connect all of us, right? Who's that guy? Okay. So I can hear it from you guys, even though you guys are mute, I can still guess that. It's ISP, Internet Service Provider. Okay, that guy, he's a person. What his duty is? His duty is, everyone, you got your own LAN network. Everyone has got their own LAN network. But his duty is, he is trying to connect all the LANs together. Okay, so he'll connect this LAN, he'll connect this LAN, he'll connect this LAN. Okay, that is what the duty of ISP is. ISP's work is to connect all the local area networks. So when you connect all the local area networks in the world, you basically get internet, right? You basically connect internet. Okay, so let's understand like this. Okay, now the ISP is there. I think this guy is ISP. The ISP means who's ISP, right? What ISP, what devices ISP will have? ISP will have full of routers only. Okay, if you take one ISP will thousands of routers, right? And there are so many ISPs in the world. I can say in India itself, we can count up to 10 ISPs, right? If you take every country, they have got their local ISPs over there, and all the ISPs are interconnected. So if you take Jio as an example, or Airtel as an example, Jio is connected to other ISPs in other countries. For example, assume that there is a ISP called AT&T, who is very popular in US, and this Jio and AT&T, they have connection. Right? And if you take Airtel, right, Airtel will have connection with AT&T, right? And Jio and Airtel will have interconnection. All the ISPs, they are interconnected. Okay. So yes. So now, what the basic idea is? The ISP. I'm just gonna put this as one single box thing. But this ISP is a huge network, right? They are very big. So here I'm just mentioning one name called ISP, but assume that whatever ISP Jio, Airtel, ACT, Hathway, Odido, AT&T, whatever company it is, they are inside this. Okay, this is an ISP network. The ISP network is so complex and so big. Okay, now we get connection. Now this router is connected to the ISP, and this router connected to the ISP, this router connected to the ISP, right? Okay. Now the ISP is connecting all of this. Now, once the cable connection, right? The connection means, I mean by the cables are laid. The cable going out from your home router to the ISP, from this guy, ISP, from this guy, ISP, everyone connects to the ISP. Okay. Now, assume that this is very serious case. You just wanted to understand this very clearly to understand the purpose of it. Okay. So here, this PC wanted to access google.com site here, right? Or you wanted to access this server. So how will generally access? Okay. Generally, we know, right? We will be accessing Google with the domain name www.google.com. I understand that, right? You access Google website with the name, but here always understand, we covered DNS concept in our course, right? So when you use google.com, what is happening? DNS is working, and then you know the IP address of you are getting, you get to know the IP address of the google.com server, and you are traveling to google.com server with the IP one, right? So instead of using google.com, right, I would like to take an example like this. Assume that I took my browser, I'm taking my web browser, okay? I'm typing the IP address 10.0.0.2, right? Assuming that I wanted to go to google.com's, I want to go to Google's LAN network. I need to go to this Google server. What is the IP address? 10.0.0.2, right? So I took my browser. Instead of typing google.com, I assume that I'm typing 10.0.0.2. Now what happens? Now the request will go out of my PC, correct? It's going to go out of my PC. Now what will be the source and destination IP? So what is the source IP? Source IP will be 10 point, sorry, what will be the source IP? 1.2. What is the destination IP? 10.0.0.2. Right, this is the source IP and destination IP. Right, hope you guys are agree with me. Okay. Now this PC sends the packet to the switch, and from the switch it goes to the router, and from the router it goes to the ISP, right? Yeah. What is the source and destination IP, guys? The source and destination IP is again the same thing. What is the source IP? 1 point. What is the destination IP? 10.0.0.2. Now we'll take this example, right? This packet is now traveling to the ISP, right? And now when it goes to the ISP network, what's in ISP also you're gonna have routers only, right? There also you're gonna have routers only. Now it goes to the ISP network or ISP router and asking, hey ISP, I want to go to 10.0.0.2. Right? Can you tell me how to go to 10.0.0.2? Do you think ISP will forward your packet now? Because you say what? You say that you want to go to 10.0.0.2, and you believe that 10.0.0.2 is IP address of Google server. But understand, like, it's a LAN network. Like Google Office, there are billions of, or maybe at least millions of offices in their LAN network. They can also have 10.0.0.2, correct? Understood? So millions of offices there, billions of offices are there, but at least in that billion, at least a million might have 10.0.0.2 as a IP address in their organization. Can you understand? This is free, guys. This network is free. Any organization can have their own network setup with 10.0.0.8, 0.0./8. So in that case, like Google, you can also have Facebook, right? What if Facebook is also having their own server? Facebook is having their own server. That server is also 10.0.0.2. Right? Assume that Amazon, they have their own server that is also having 10.0.0.2. Right? You can take multiple examples. Please. Now, what happens here is, since the private IP addresses are free, I told you earlier, since they are free, anyone can have their own network setup with any of these series. And many organizations use 10, many organizations use 172.16, many home users and small organizations, they use 192.168. So now there is no proper way to go to 10.0.0.2. Why? Because there are millions of 10.0.0.2 in the world, because these addresses are free to use in their organization. Everyone, like how Google Office decided to use 10.0.0.0/8. Any organization can use the same network in their organization, and in their organization, they can have one PC or one server with a IP address of 10.0.0.2. So now what's going to happen is, when you go and say, right, let me just write this again. When you go to the ISP and say, hey, ISP, I want to go to 10.0.0.2, and I'm coming from 192.168.1 point. If you say this, the ISP will see the destination IP, and it says, hey, your destination IP, the IP that you're trying to reach is 10.0.0.2, which is what? It is a private IP, right? So this 10.0.0.2 is in many locations in the world. I don't know how to go directly to 10.0.0.2 because it is not unique. Can you understand? It, what if every street has got the same name, right? Assume that there is a, we have many streets, right? What if every street or every house has got the same name? Right? There is a lot of confusion, right? So that is what ISP is saying, right? If you want to go to 10.0.0.2, then there is no way that I can route you to 10.0.0.2 because there are millions of servers or millions of devices having the same IP in their local area network. So one thing is very clear. So ISPs will hate, or I can say they'll hate, or they are hating private IPs. So if you hate private IP, so if you wanted to go to internet, or if you want to access, or if you want to go through the ISP, right, you cannot do it with private IPs, right? So ISPs, they never like private IPs because private IPs are not intra routable. Private IPs are not internet routable. You cannot go into the internet and come out. Okay, let me just draw this like a cloud. Okay, there is more. Okay, okay. So this cloud is internet cloud. So if you want to go into the internet, you cannot go with private IP. Okay, so now what happens is Google Office is understanding it. Okay, so if they have their server with this 10.0.0.2, anyone from their office, right, they cannot reach, right? This guy cannot reach, this guy cannot reach. No one in the world can reach this server because they have 10.0.0.2 IP address, which is a private IP, which the ISPs will never route. So what Google decided is, see, now this guy can reach. If this guy can reach, he can reach. But the Google server is set up for whom? It is set up for everyone in the world, right? Everyone in the world should reach the google.com server. That is what the main target, right? The google.com server is not built just for this guy to reach. It have to be reached even from this guy. It have to be reached even from this guy. So for that, they decided if I use a private IP for me, or if I use a private IP in the server, it's not going to be working right, because ISPs will never route to me if the destination is 10.0.0.2. They're never going to forward it to me. Okay. So Google decided to buy a public IP, right? So I told you, public IPs, private IPs are free. Public IPs are something that you have to pay. To whom you have to pay? See, basically you pay to the ISP one day, right? So whatever ISPs that you have, you basically pay to them. I'm not going to get into those nitty-gritty things and all here. Let's simply understand that Google is buying a public IP, and now they set up their network with public IPs, right? Assume that, let me just undo this. Okay, okay, undo is not working. Okay, let me just erase this. Okay, so now instead of having a private IP in their organization, they used to go with a public IP. So they decided, okay, I'm not going to use a private IP. Private IPs are free, but I want a public IP. I'm ready to pay. Google is paying some amount of, some amount, and they are getting a public IP. So assume they got a public IP. Assume that they got 100.0.0.0/24. Assume they got this public IP chunk. They got this public IP. Now they're gonna have a local area network only, but that local area network is built with a public IP. Okay, so 100 is public IP. Now can you see? This is 10 is private IP, but 100 is public IP. Okay, so here we're gonna have 100.0.0.2 this guy. Okay, 100.0.0.2, it's a public IP. This guy 100.0.0.1. This guy 100.0.0.2. Sorry, 2 is already there, no? 3. And this guy 100.0.0.4. Now, the whole Google Office has been converted to a public IP. Okay, now these IPs are unique. That is very important. So what is the difference between public and private IPs? See, private IP, any organization can use. It's their choice. Right? You can pick 10, you can pick 175, you can pick 198. So when you let the users to pick their own private IP addresses, that is where, the duplication happens. That is why when you ask them, anyone can choose any range in any private IP range, then many people will choose 10. Many people will choose this guy. Many people will choose this guy. That is why the duplication of IP address is coming, right? Private IPs are not unique. Private IPs are available in multiple places, right? The same IP, right? If I have this IP in my home, this IP, I'm sure that the same IP address many devices in the world will have, right? Inside their LAN network. Okay. So if now what happens is these public IPs are payable, right? So which means this public IP is not in multiple locations. They are only in one location. You pay and get a public IP. So which means you are the only one who has got that public IP. No one in the world will have that public IP. Google got this public IP. No one in the world will have that public IP within, right? No one, this is only with Google. Okay. Yes. So Google Office, they spoke to their ISP, and ISP gave them a network of public IP. Now this is a public IP range, and now they configure all the devices in their network with that public IP, which is 100.0.0.0/24 network. Okay. Now things are good. Now what we'll do is, now install this guy. Right now, this guy will not use 10. Earlier he was using 10. We all understood that's not going to work. Now Google converted their network with a public IP. Now the server's IP address is 100.0.0.2. Now let's say this guy is typing 100.0.0.2. I press in his browser to reach the Google server. Now what happens? Now what will be the source and destination IP? The source IP will be Source IP is 1.1 only, no, that doesn't change. Destination only now changed. So the source IP is 1.2. Now the destination IP is 100.0.0.2. Okay, so now this packet leaves this PC, goes to the router, and from there again it's going in this direction. Okay, yeah, listen, now the packet, the same packet is traveling. The packet which has got 1.2 source IP, which has got 100.0.0.2 as a destination IP. Now this packet is traveling to the ISP and says, hey ISP, can you route me to 100.0.0.2? I need to reach 100.0.0.2. Can you route me? So ISP sees, okay, the destination is public, right? Where is 100.1.1.2? Who purchased 100.1.1.2? Google, that company purchased it. So he very well knows that 100.0.0.2 is unique. It's not a private IP, right? It's a public IP. So 100.0.0.2 is only in one location. So he is ready to route. Fine. But what is the source? Can you see the source IP? What is source? Source is private, right? The source is coming from 191.1.2. The source IP of the packet is 191.1.2, but the destination IP of the packet is public, right? The source is not unique, guys. The source is not unique, but the destination is unique. What decision the ISP will take? Will he forward the packet or even discard the packet? What do you guys think? Okay. So of course, it's gonna discard it. It's gonna drop the packet. Why? Because again, assume that if he routes this packet, if he routes it, now when the reply comes, who will be the source? If the reply comes, this guy 100.0.0.2 will be the source, but who will be the destination? This packet went, and the reply is coming. Reply, who will be the destination? 1 point, right? Now, can you ask ISP to route the packet to 1.2? Because there is many 1 point, right? You have 1.2 here. You have 1 point here. What if, ISP by mistake routed to this 1.2 instead of routing to this 1.2? You got the point? So now again, in this example, the reply, in the reply, the destination is private, which is not possible to route anyway. So what the ISP will decide is the moment when he enters, I mean, he'll just see in the initial process when the packet is coming into the ISP, that time itself he'll see the private, I mean, the destination IP should be public. At the same time, what should also be public? The source should also be public. The source IP should also, if both are public, then only then the ISP will consider this packet as a valid packet to route. Okay. So if this guy is private or if this guy is private, then it becomes an invalid packet. So those IPs or these IPs are what? These IPs are not internet routable IP addresses, right? And there is a reference in RFC that is 1918. There's nothing but a number base, right? If you just go and search for the documentation, you will know what a private IPs and all we have got. So this number, just every time when IANA decides something, they release that in the format of RFC. So you can just go and read the documentation. Okay, so RFC 1918 says that these are private IPs, and the private IPs are not internet routable IP addresses. They are used only in the LAN network. You can use it, you can locally communicate, but you cannot cross your LAN network and you cannot travel into the internet with the private IP. So what do we do now? Again, we have a problem. Okay. So now what happened is this company A also decided. The company A, let me just undo. Okay. The company A also decided to buy a public IP, right? How Google Office purchased a public IP 100.0.0.0/24. Company A decided to buy a public IP. Okay. So now they decide to have a public IP. For example, assume that they decide to buy a public IP like 150.1.1.0/24. Okay. Again, they purchase this public IP, and now this public IP is unique, right? No one in the world has got this public IP, like this range of public IP. So now they are just restructuring their network. Now instead of giving private IP to all the PCs, they are giving public IP to all the PCs and devices, right? Assume that they are, this guy is 150.1.1.0, sorry, 1.1.2, right? And you have got a gateway which is 150.1.1.2. Now again, I'm just restructuring my whole network with public IP list. Okay, now think, this guy is public, this guy is 150.1.1.2, and all the devices in this organization is also public, and Google Office is also public. Now, can they talk? Right? Now, if I open this PC, and if I say I want to go to 100.1.1.2, or what is it, 100.0.0. Okay. If I say I want to go to 100.0.0.2, right? This is the IP address of this PC, and we are taking a browser and we are typing this IP address. Now what happens? Now what will be the source and destination IP? The source IP is going to be 150.1.1.2 because that is the new public IP the company A purchased. And now here 100.0.0.2, that is the Google server's IP address which Google server purchased. Okay, now they're going to travel like this. Now here when you go, the source will be what? 150.1.1.2. The destination will be 100.0.0.2. Now, do you think this packet is valid? Yeah, very valid, because why? There is only one device in the world which is called 150.1.1.2. There is only one device in the world which is called 100.0.0.2. Both are public APs only. Now this packet is a valid packet. Now the ISP will route, everything is fine. But if everyone starts purchasing public AP, that's what the point is. If everyone starts purchasing public AP, like how company A, they got a public AP, 150.1.1.0/24 network. And now company B is also purchasing. Maybe assume that they are purchasing 200.1.1.0.0/24 for their organization. See, if every company starts purchasing a public AP, every home network users start purchasing a public AP. If everyone starts purchasing a public AP, again the same problem happens, right? What was the initial problem? The initial problem was what? The initial problem is shortage of IP address. We don't have, now you can see now, if everyone purchases a public AP, we take 97%, somewhere around 360 crore IPs only we have here. If everyone starts purchasing the public AP, so we have many networks, billions of networks, and if everyone starts purchasing public APs, again the same problem will happen. We'll run out of IP address. Okay, this guy purchased, everyone purchased, right? Everyone wanted to purchase. The IP address ran out, right? Again, many networks will not have any public AP to purchase. You got the idea what I'm trying to say? Okay, so now public APs are limited. And if you if organizations buy public APs, and if they start using public APs in their own network, of course the public APs will so quickly run out. Okay, so then what do we do? Okay, this is what the the beauty of network address translation is. What happens is, now what I was earlier explaining, right? I was earlier explaining, no, 150.0.0. Sorry, maybe 150.0.0. Or maybe I'll say 1.1.0/24. I think this is a network that this guy has got. Now, instead of purchasing the whole network, like in this network, how many IPs we have? 256 IPs, correct? So we have 256 IPs, right? And that 256 IPs used for all the PCs. This PC, everyone has gotten in the individual public IP. So now, instead of doing it in this way, what we can do is, right, instead of purchasing the whole public, see, if this guy purchases the whole network, 256 IPs are used by this organization. Right? Every organization starts purchasing a public AP network, will run out of IP address, right? So how we can optimize this? Instead of having everyone having a public AP in the device, if you have 100 PCs, instead of all 100 PCs having a public AP, instead of having all 100 PCs having a public AP, we can have one public AP on the router. Yeah, this is what the idea of network expansion is. We're going to have only one public AP base that is going to be on the router, right? Assume this organization, instead of purchasing 100 public APs for 100 PCs, they're going to purchase only one public AP. Okay, they're going to purchase only, they talk to the ISP and they're going to purchase only one public AP, and that public AP will be configured on routers this side. Okay, this side 1.1, on this side it's going to be 150.1.1.1 or something like that. Okay, and the same way, this company B, instead of purchasing 150 public APs for every PC in their organization, they're going to purchase one public AP, and that public AP will be configured on this side. Example, they have 200.1.1.1. Okay, so now if you understand this setup, this one public AP is commonly shared. This one public AP is commonly shared by all the devices in that network. If you have hundreds of PCs, all the 100 PCs will be using one public AP to go out. Okay, which means if I take this PC, he travels, and when he goes out, he'll be taking this public AP and traveling. And when you take this guy, he'll again, when he goes out, he'll be taking this public AP and traveling. So I'll tell you exactly what happens right now, guys. So now assume this is the setup. Okay, the setup is you have got one public AP that is going to be shared by all the devices in the network. Okay, so now assume this PC takes his browser and typing 100.0.0.2, which is the IP address of Google server. Okay, Yes. Now, after typing, what will be the source IP address? When the packet goes out of this PC, what is the source IP? Wait. What is the source IP? The source IP address is source IP is what? Source IP is 1 point, right? This is the IP address of the PC. So, which is a private IP, 1.2. Now, what is the destination IP? 100.0.0.2. Okay. So, source is private, destination is public, right? When we send the packet out of this PC. Okay. Listen to me carefully. Here, going out with this, right? This is the source and destination IP going out. Now, when I send the packet to the router, generally what router will do is, general router will forward the packet, right? That is what we know. Router will get the packet and forward this side. That is what router means, routing. It will do the routing. Now, we're gonna ask this router to do what? We're gonna ask this router to do network address translation. What we are asking to do? We are asking to do network address translation. So what happens is, when you see in this direction, the source IP address of the packet, the source IP address of the packet is having 1.2. I think this is what exactly this. Okay, now what route will, when he routes the packet on this side, you're gonna change the source IP. Understand? This is gonna change the source IP. When the same packet is going out of this router and before going to the ISP, this router should do NAT. Right? What he'll do, what I mean by he need to do NAT, he need to change the source IP. So the real source IP is 1.2, but router should not send the packet with 1.2. Instead, what he'll do is he'll take this real source IP 1.2 and put this source IP address which is public. Okay, so now after this is before NAT phase, this is before NAT. Now this is after NAT. So after NAT, the source IP will go, the source IP will be 150.1.1.1 and the destination IP will be 100.0.0.2. Yeah. So now this will be the source and destination IP. This is the new source IP, which means simply the router takes the packet, removes the private IP in the packet, and puts this IP address in that packet and sends the packet into the internet. Okay. Now, when the ISP gets this packet, what the ISP will do? The ISP will check whether the source is public and the destination is public. If both are public, then he'll send the packet. Now the packet is going to go to this side and it's finally going to go and touch the google.com server. The reply will come. When the reply comes, what will be the source and destination? Will be the reply. Source is coming from Google, which is 100.0.0.2. Destination is going to that whom? That company A. It's going to the company A router. Okay. What is it? What is the IP they purchased? 150.1.1.1. Now, this will again go to the ISP. Again, ISP will know which customer buy or which customer bought 150.1.1.1. He'll forward that customer's router, okay, which is this guy. And now this router, what he'll do is again, he'll get the packet back. And now when the packet is returning, right? When the packet is returning to the router, what is the source IP? The source IP is 100.0.0.2. What is the destination IP? The destination IP is 150.1.1.1. Now, when you get the packet, right, I don't have space here to write this, but I'm just saying here, when it goes, now the router have to route the packet back to the PC, correct? It have to route back to the PC. That time, what you do is, when the packet is coming back, when it comes back, it comes with 150.1.1. But when you route the packet to the PC, you need to change that back to what? You need to change it back to 1.2. Okay, 1.2. Right? And then, now if you see in this link, this is the incoming, this is the returning traffic. Returning traffic will come from 100.0.0.2. What is the destination IP? 1.2, right? 192.168, 1.2. Got it? Yeah. So this guy comes over here like this. Okay. So now what happens? This guy, when he goes out, very simple, right? We have 1.2 PC. You have a router connected, right? Router is connected to the internet. Here you have Google server with the IP address of 100.0.0.2. And this is the public IP 150.1.1.1, let's say, right? And here you have your gateway. So simply I'll tell you. Now when the PC sends the packet, source IP will be 1.2, destination IP will be 100.0.0.2. This is the original packet. Router will do what? Router will do network address translation. What is network address translation? Before sending it into the internet, the router have to take the real source IP address in that packet and he have to put this IP address, right? This is IP address that is configured to the router. Okay. So you need to change it. So changing the source IP address 150.1.1.1 and then sending the packet to internet 100.0.0. So you just changes this one alone. Change the source IP from 1.2 to 150.1.1.1 and you can send it into the internet and it just goes and flies and finally reaches this Google server. In the return packet, return will be from 100.0.0.2 coming back to 150.1.1.1 1.1.1. Again, it comes from Google, so it comes to the office router. The office router will now do reverse translation. That's what this is a source and destination, no? But who's the real destination? Who's the real receiver? 1.2. So in the packet, when this reply packet is coming here, we're gonna route it to the 1.2 PC, but this 150.1.1.2 will be changed back to 1.2, and the sender is Google's IP address, which is 100.1.1.2, and this PC gets it, which means the PC sends the packet with the source IP address of 1.2, receives the Google's response to his IP address, which is 192.168.1.2. Okay, but which means this PC never knows, right? That's what the thing is. He never knows. He never knows that the router is changing the IP address in the packet. The PC is simply sending it, and the router stops the packet, changing this, removing this, and put his IP address, sending it to the internet. When the reply comes back, again taking his original IP address, putting his 1.2 IP address, and sending it back to the 1.2 PC, right? So this is what network error translation. In this case, what happens is, right, when NAT is implemented on this router, this 1.3, 1.4, any devices, all the 100 PCs in this organization, when they go out, they'll be using this public IP and they'll be going out. Okay. Now I'll show you guys even here. This is my IP, right? This is my private IP address, right? This is my PC's IP address. But when I go to Google, right, when I go to Google, and I'm going to search for show my IP. Okay. So what is my IP, guys? What is this? Right. If you understand my home network, assume like this, right? This is my home network. Application. Okay. So you can very well understand what happens here. Okay. So if I explain my home network, this is applicable to you also. You guys also can go to Google and search for show me IP. Okay. So this is a Google server. Okay, this is my home router I have got at my home, and there assume that I have got a switch here, and this is my PC. This is where my PC is connected. Assume that this is my other PC that I have got. Okay, so in my network, if you see the private IP that I use here is 192.168.229, sorry, 168.29.1. Okay, and here assume this PC is 192.168.29. What is this guy? We got 29.226. Okay, maybe this PC is 192.168.29.227, let's say. Right? And assume that you have few more PCs in my home network. When I go to internet, when I send the packet to the router, I send with my real IP address. Okay. But where is that public IP configured? Where is that? But how these guys they are saying? Okay, wait, let me explain to you. Okay, so this is IP, that is my public IP. That is configured on this router interface. 49.37. 217.184. 217.184. Okay, this is IP that has got, this is the IP that my router is having. So when I go to internet, my source IP, the PC sends the packet with this source IP address. But later, what happens? The router changes the source IP from this, and is sending any packet that this PC is sending. The packet goes with the new source IP address. I mean, what is the updated source IP? 49.37.37.217.186. And now my packet goes to the Google server with what source IP? It's going with this source IP. That is why I say, right, when I go and ask, hey, Google server, can you show my IP address? What is the IP address? How you see me? And when I ask Google how he sees me, he's saying that, hey, I see you with this IP. I see that your IP address is 49.37.217.194. But the reality is my PC is having what IP? It has got 192.168.29.226. Okay. So yes, so like this, right? This is my home example case. Like this, everyone's home network is same thing only. And also understand, if I take this PC, right? If I take this PC, and here also if I go to the same, right? Here I'm taking this PC, right? Now I showed you from this PC. Assume that I have one more PC at my home. If this PC, if I just go to the Google, there also, what is my source IP? The source IP will be same. Because why? Because if I have 10 devices at my home, if I have 10 devices at my home, all the 10 devices will be sharing this public IP to go to internet, right? So sharing public IPs, that is an important point, right? So when you have 100 PCs, if you start giving 100 public IPs to all the 100 PCs, then we'll run out of public IPs. This is wrong. You'll run out. So instead, you can have 100 PCs. 100 PCs, let them have a private IP. Right? Private IPs are free, anyone can use now. They can have private IP. But when they go to internet, what router will do? The router, all the 100 PCs will be sharing one public IP. And how that sharing is done? You send a packet with your source private IP, but the router will be using, you'll be updating the source IP address from private to public, right? So many people will say, if you just go and check in the internet and all, what is NAT? Okay, some people say, changing a private IP to a public IP. Okay, so that is what NAT is, but actually that is not the correct statement. NAT is not changing a private IP to a public IP. That is kind of sensibly right, but the real meaning of NAT is changing the source IP, right? If the source IP address of the packet is changed, okay, then that is called as NAT. Here, we are changing the source IP address. We are changing this source IP into this source IP. This source IP happens to be private. This source IP happens to be public. So it is getting allowed in the internet. Okay. So got it. So here, I just want to do a small lab on this. Right. I know the theory part is really big. When you take network address translation, making students understand the purpose of NAT. First, we have to tell them the problem, and then we have to give them the solution. I know it will hardly take 1 hour of time to explain what is network address translation. Yeah. Okay. See. Okay. So I see some chats in the chat box. Okay. I'm just gonna proceed here. Okay. Let's close this. Okay. I'm gonna get into my CCNA and copy the lab to you guys. Network address translation. Where is NAT? Okay. We have multiple NAT labs here, but I'm just gonna go and give you this lab alone. So I'm network address translation. Okay, move here. Okay, 3 labs. Good. Okay, here in NGP labs, we're gonna have CCNA bootcamp, and I'll just rename this as 994. We'll have that file and just NAT. Okay. Okay. So yes. Okay. Here you have it. Okay. We rename it again. I don't know why it is here. Okay. Anyway, I'll open this. NAT this file. Okay, open the file. And now you have a very simple example here. So this is my college actually. Maybe if you guys know SSM, I'm from SSM. And I just created this topology with a couple of scenarios. Okay. Yeah, so here you have SSM college, here you have SRM college. Both the colleges, they want to access internet. Okay, in that case, how it works. That's what we are trying to understand here. Okay, I'll do the lab on this. Maybe I'm just going to start all the devices. Yeah, so meanwhile, I just wanted to say one thing. I already mentioned that people are watching the recording. Maybe if you're really interested in taking the CCNA full course days, which is going to commence from 28th of August, yeah, which is just day after tomorrow. Maybe people are watching the recordings. If you're watching it post 28th August, you can just go and check our website, w.networkgeek.in. Yeah, there's a website, networkgeek.in, and there you can find the upcoming batches. And you can see there's an upcoming batches. You can choose CCNA, and there you have Monday to Friday, 6:30 p.m. to 8:30 p.m. It starts on 28th August, right? Maybe if you are looking for any upcoming batches, maybe you are watching recordings 6 months later. At that time, you can again go to the same website and check the upcoming batches over there. Okay, so if anyone is interested to take the complete CCNA course, this is a basic course, right? I know I planned it for 30 hours, but actually I think the runtime is only 20 hours of content, right? We were able to complete. Okay, anyway, so if you want to go with the CCNA full course, you can just go and enroll for this CCNA full course, maybe the immediate upcoming batches or maybe in future also, or you can join. Okay, so there you can understand, there I spend more time on every topic. And so usually 120 hours is what we spend in the actual course, but here somewhere around 20 to 30 hours is what I planned for. I just finished it with 20 hours of time. If you want to have a deep knowledge in CCNA, you can just go and check that CCNA full course. That is not a free course, guys. That is a paid one. The moment the pricing is 8,000, maybe it may change in future. So, yeah, so please just go and check it. And also, if you want to see the syllabus, you can go and go to the CCN, upcoming batches. You can go to the courses and CCNA. And here the pricing is updated. Right now the pricing is 8,000, and these are the topics that we are actually covering. Okay, so this is for online students right now. This is for recorded session students who are wanted to take the complete course. Like that's available, but that's not a free course, it's a paid course. You can check that. Okay, so yes, coming back to this. Okay, here you have a couple of labs. One is SSN College, other is SRM College. And SSN College, they have got a public AP. They purchased this public AP. They're going to share with all the college students. They're going to share this public AP to go to interview. Okay, so let me just go and do the real quick. Here we're going to go and create. Okay, so here I have, okay, let me change the host name to SSN router. Okay, from SSN router, so first let's check the IP address. Do show IP interface brief. Do we have the IP address configured properly? Yes. This is a private interface. This is the interface to the organization network. This is the private IP. That is connected to organization network. And here you have another, this is a public IP, right? This is the one that you purchase from your ISP. Your ISP will give you some IP that you have to configure here. Okay, so there's one already configured 100.200, sorry, 200.100.100, 200.1.1.1. So that is on the other side, gigabit 0/0 interface. Okay, yes. Okay, so now what we're gonna do is we're gonna first how this is done, how this NAT process is done in Cisco is first you have to create an access list. Access list, and I'm gonna create a standard access list. Access list one, permit 192.168.1.0, 0.0.0.255. Okay, and we're gonna have this. So this basically says that I wanted to permit which network 192.1.0. The same thing that we covered in the last class. ACL wildcard bits it is. We discussed in OSPF also. Okay, so it says that I want to do NATing for all the 192.168.1 network. Okay, that's the meaning of this. Okay, next is I just want to create the first thing is you have to create an ACL base. That is the first thing. Next thing is you have to create a NAT line, network address translation, ACL, network address translation. I mean, that in that NAT you have to call this ACL. See, right now when I try to try to reach this from here, from now NAT is not being done, right? If NAT is not done, then we'll see what happens. If NAT is not done, right now no NAT is done. Okay, we'll just try to access the internet from this guy. Okay, when you try to go to Google, it's not going to work because why? Since NAT is not done. Okay, see, it is not working because the reason is because now NAT is not done. So you go with 1.2 source IP to some Google destination IP, and your router is not doing NAT. What is simply doing? He's simply forwarding your packet to the ISP with the source IP of 1.2 itself. Okay, the ISP sees the source IP and he says, hey, no, you are coming with a private IP, so you're not allowed to get into the internet. That is why he's blocking. Your packet is getting blocked on this place right now. But once we do NAT, we'll not go with the source IP of 1.2. Instead, we'll go with the source IP address of what? We'll go with the source IP address of 200.1.1.1. Okay, that's the new source IP address. After NAT, this will be the new source IP. That time the ISP is convinced and he'll allow the packet to get into the internet. Okay, that's what the plan is. So yes, we're gonna do NAT right now. So internet is not working in this PC right now. No internet, it says no internet, but don't worry. Once the NAT is done, we're gonna get internet. Okay, so IP NAT inside. This is the NAT line. IP NAT inside source list one interface G0 slash 0. Okay, I'll explain what is that mean, right? Okay, so let me just ACL line and then NAT line. I'm just gonna explain these two things right now. So what the first line says is, the first line says we are just creating a normal ACL. There is the number of the ACL is one, and permitting it, and which we are permitting any traffic that is coming from 192.168.1. Any PC has got IPs that is starting with 192.168.1. We are permitting it, right? So indirectly, this line says that permit 1.0 network. That's what it says. It simply says permit 1.0/24 network. And then the second line, IP NAT inside. So this is where the exact NAT happens. This is what the NAT line is. This is important. IP NAT, I want to NAT. And I want to NAT what? I want NAT inside network. So usually you can categorize networks in two ways. Right? So wherever you have clients, that is what called as inside. Okay. Wherever the internet is connected, that is called as outside. So internet is outside. our organization network is inside. So LAN is inside, WAN is outside. Okay, so here I say I want to NAT. I want to NAT the inside. I want to NAT the inside network. Inside network means I want to NAT. I want to do NAT for this network. I wanted to NAT the source IP, right? So when someone is sending the packet, I want to change the source IP address of that packet, right? That's what I mean there. So I want to NAT. I want to NAT the inside network. I want to NAT the source IP. I want to change the source IP address in that packet. And inside network is given in this number one. Where is this number one? This one. Can you see this one is called here? Okay, so I want to NAT. I want to NAT the inside network. I would NAT the source IP address of the inside network. Inside network is given in list number one. And when you translate, use the public IP that this interface is got. You say that this interface is having public IP. Okay, if you see what public IP has got 200.1.1.1. So I say anyone from this network, anyone from one point network, if they are going outside, they have to use the public IP address 200.1.1.1. That is what we are saying. Okay, and after that we have to configure a couple of things. So interface FA, so interface G0/0. So the outside interface case, since that is an outside interface, this guy I went into this interface since that is outside. I want to say that this is outside interface. What I can do that is I'm going to the public IP interface and I say IP NAT outside. Okay, and next thing is I want to go to interface G0/1 and I say IP NAT inside. Okay, so 0/1 is what 0/1 is this guy, this guy, this is inside, no? So I say this is inside. Perfect. Right. And finally, one more thing we have to do is we have to configure default routing also, right? That is one that thing is very important. By doing that, you get translated, but the default routing, right? You remember what is default routing? We discussed in the class. The route for internet. You have to do routing for the internet. Okay, that routing should be done. Default routing. So the command is IP route for any destination. That's what IP route says 0.0.0.0, 0.0.0.0 for any destination in the world where I wanted to send. I want to send the packet to my ISP, okay, 200.1.1.1. So routing should also be there, guys. At the same time, NAT should also be there. 200.1.1. Isn't it? Yeah, correct. So now what we gonna do right now is this. We did NAT, we did default routing also, everything is good. Now from here, assume that from here, 1.2, I'm trying to go to some destinations in the internet, assume 8.8.8.8, this public IP. What happens? The route will check the routing table. And where is 8.8.8.8? It knows that it is on the ISP. So now the router will prepare to forward the packet on this interface. Before forwarding the packet on that interface, it's going to do NAT. Right? So now the source IP will be changed from 1.2 to what will be the new source IP? 200.1.1.1. And the destination IP is 8.8.8.8. Right? Now when this packet goes to the ISP checks the source and destination IP. Since both are public, he'll forward it to the internet. And you'll get the response back. And in the response, you will have this as a destination IP. Again, this destination IP will be again changed back to 1.2, right? Which means NAT means simply I can say, while the packet is going outside, change the source IP. That is what NAT. And when the packet is coming back, right, change the destination IP and put the original IP address back. So when you change source IP, you're changing to a public IP, correct? The source IP becomes public IP after NAT. So again, the reverse NAT should happen. The reverse of that, the destination IP, which is public when it comes to the router, again it have to be changed to what? Back to what? It have to be changed back to so private. So before, while you do NAT private to public, that packet is going on this direction. When the packet is coming back, public back to private, so that this guy will get the packet to him, and the destination IP in that packet is 1.2 itself. So I've done finally what to do is we have to just make a refresh to check whether it's working or not. Can you see cool it's working? Okay. So now I can search for network leak also. It works, right? So perfect. So this is what network cancellation is. And now if you have now thousands of users over here, all thousands of users will be sharing one public IP. They'll be using this public IP to go outside. Okay, and if you take SRM college, the same thing is done here. I'm not going to configure it here, but I'm just going to tell you when these guys are going outside, they're gonna take this public IP and go to internet. Right? All if you have some 5,000 students over here, 5,000 users over here, all the 5,000 users will be sharing this public IP and going outside. Okay, and NAT is a huge topic, guys. Right? NAT alone will take 10 hours to completely explain what is that. But no, I just took some 1 hour, 15 minutes to explain what is NAT. I did the same basic lab here. There are many other NAT concepts are still left. Don't think that this is what the complete NAT is, right? So we just covered only 20% of NAT right now. We understood the problem and we understood what is NAT. That is 20% of NAT. So 80% of NAT is also there, which is we call the static NAT, dynamic NAT overload, right? So port forwarding, multiple NATs. So there are there many NAT concepts are still left behind. Okay, so which you guys can learn maybe anywhere you want. But just understand that you are not completely understood NAT. Right? We just understood NAT, but not detailed, not in detail. Okay, so yes, I'm just finishing NAT over here. So just I just spend some 10 minutes of time just to understand, just to give you clarity on what a firewall is. I'm not going to discuss huge about firewall, but just 10 minutes about firewall, and then we're gonna wrap up this boot camp here. Okay, yes. See, firewall is actually a very interesting subject. Is firewall. When the moment when I learned firewall, I really felt it's very interesting. When I learned CCNA, I felt CCNA is awesome, right? But the moment when I learned network security, that is specifically a firewall, I started learning my firewall content with ASA. That is a Cisco firewall. ASA was good firewall, it is fine. But the moment when I learned Palo Alto firewall. Hey, that is where I really love firewalls are really awesome. Uh, I'm not promoting anything, guys, and it's completely up to you. But we do also have Palo Alto firewall courses going on. Maybe not right now. We don't have any batches scheduled, but we have some batches for we have some batches in future. But generally for upcoming batches, if you go with the Palo Alto firewall, we have recorded sessions immediately available, right? And only 70 hours of Palo Alto firewall recordings we have. Okay, so yes, so firewall is an awesome subject. I'll just tell you what firewall, what are the features that you get, what is the difference in firewall and a router. Those things alone I'm trying to explain you. Okay, so Palo Alto, and then after that I learned the Checkpoint also. Okay, Checkpoint firewall. That's another very good firewall company. And also FortiGate is still in the they are leading in the market, but I don't have much experience in FortiGate. I know the firewall is same thing only, right? If you learn Palo Alto, the same thing, right? You can easily learn FortiGate also, but FortiGate I have not worked with it. I know ASA I have done, Palo Alto I have done, Checkpoint I have done, but not with FortiGate. I need to spend time, but I don't have time to learn FortiGate. But that's again a very good firewall. So if you learn Palo Alto or FortiGate, right? Or if you learn both, then definitely you'll have a very good opportunity in firewall industry, which is a network security team, right? So you can get into a network security team, and you can be a very important resource in that company, because security is very important always, and firewall is a best place to learn more about network security. Okay, so now let's try to understand what a firewall is. See, simply, firewalls are in two ways, please. Firewalls in two ways. One is a software firewall, but they are not that big, they are not that demanding. Okay, the other one is hardware. Hardware means the firewall is a appliance. Okay, so this is basically an application, right? And you might have seen when I search for firewall in my PC, or every mission has got. Can you see a Windows Defender firewall? Okay, I can turn off a firewall, I can turn it on. Right? So those things are fine. Okay, so you can have inbound rules, outbound rules. So basically, it's nothing but kind of an ACL only, right? So it's an ACL that you have in your you have an ACL in your PC. That's a software firewall, just an application firewall. That's not that great. But hardware firewalls are really, that is where the market is actually. I was talking about ASA, Palo Alto, Checkpoint, FortiGate, right? So they have their own appliances, right? It can be a virtual appliance. Some organizations they go with virtual appliances. Some organizations, on 50-50, I can say, they with physical box, right? So they have a firewall physically in their organization, like how a router looks like. They have a firewall too. Okay. So what are the advantages what we have, and what are the difference between router and a firewall? And tell you. See, you cannot compare router with a firewall base. So router is something different, firewall something different, right? So it's like you compare a car with a bike. So they both have their own advantage, disadvantages, right? Bike, it's easy in city, right? You can easily travel, but car again, it's a different thing. See, it's like people there are specific reasons where you need bike. Yeah, there are specific reasons where you need car. Okay, maybe if multiple people wanted to travel, car is better, right? Or maybe if you wanted to go fast, or you just wanted to go into the traffic very easily, then bike is better, right? So that is what I would say. The difference between firewall and router. You should not compare it actually, because they are designed for a different reason. Router is designed for what? Router is designed for routing the traffic. Okay? Routing the traffic. Where routers are generally used? So routers are generally used, if you're a home user, most of the home users, home networks, you have a router. That's basically the home router. So every home user have a home router. And apart from that, where and all you can find routers. Of course, organizations also they have routers, but home routers are there. And next thing is, no, this is cloud, right? Internet. In this cloud, you have full of routers and right? Inside the internet, you have full of routers. Who's that guy? ISP routers. So when you open the cloud, right, there is an ISP network. When you open the cloud, it's going to be full of routers, and there's managed with different ISPs. So these are the two places where you can find routers a lot, right? As a home user, you have a router at your home, or maybe if the ISP company to get that whole ISP internet infrastructure working on, they'll have routers inside the cloud, right? So inside the cloud, you have millions of routers, and every home user they have. Now, if you have got a Wi-Fi connection to your home, you know that you have a router, right? So these are the places where routers are majorly used. Where the firewalls are used. So firewalls are used in apart from these two places. Maybe I can say any enterprise network. Any enterprise network, for example, it could be a college, it could be a company, a small company or a big company, whatever it is, right? There and all they'll be using firewalls. Okay. So firewall is a very unique device, right? It has got more functionality when you compare routers. So assume that there is an organization which has got a firewall. Okay. So now usually what we learn, routers are connected to the ISP. That is what we learn, right? But that's not true. Even firewalls are connected to ISPs. Okay, so firewall in generally in enterprise networks, uh, firewalls are more used than routers. Routers they don't use it. Routers are used in home networks and inside the ISP network. Routers are fine. You can find it more. But in an enterprise network, firewalls are widely used. Right, and then you have all your the firewall is connected to the switch. Okay, and you have these similar like router only, right? We have router and we connect that to the switch and we have these, right? Here we have switch connected to the firewall. And what and all firewall can do? See, firewall can do whatever the router can do. Whatever the router we learned so far, router can do NAT, right? It can do. Router can do ACL, right? Firewall can also do. Because the main purpose of firewall is to do ACL only. Right? It can do advanced ACLs. It can do so complicated ACLs. Okay, so it can do what NAT is here. It can do it can run OSP please. Firewalls can run OSP. It can do dynamic routing, right? It can do of course default routing. It can do whatever that we have learned so far in this CCNA boot camp, or maybe in the full CCNA course also. Whatever that we learn that is even possible in firewall also, right? Don't think firewall is something else different, right? Router firewall also has got almost all the routing features. So if you take a router and all the features of routers are available in firewall also. Right? Then if all features are available in the router itself, then why do I need a firewall? I can use a router itself, right? If router has got same feature as firewall or vice versa, then I can use that one device, right? But it's not like that. Firewall has got little bit of additional features. So what that is, these are the normal router features, guys. I can even say even more features if possible. But firewall has got its own unique features. For example, UR can do URL filtering, okay, based on the category. Maybe assume that the organization should not allow adult category websites. Okay, how they do that? With the help of router, if you block adult category websites, that is actually difficult. Routers are not designed for that. Routers are designed for what? Routers are designed for routing the traffic, right? They are not designed for blocking something. Now, URL filtering, maybe if the organization doesn't like, of course, no organization will allow adult category websites from their organization. Okay, so URL filtering, that's possible with firewall. Then what else, right? You can do, advanced inspections. I can say application filters. For example, if you say, I don't want WhatsApp to work, that's simply possible very easily in a firewall, right? And also, what else? Maybe I can say HTTPS inspection. That is one of the very important feature is inspection. HTTPS inspection that is possible in firewall. Maybe you can also do some kind of a geo-based location, geo-based ACL. Okay, ACL based on geographical location. I don't want any Chinese hackers to come into my network. So I can say I can block China. I can know in that rules I can say geo-based. I can say Chinese IP should not get into my network. I can just simply block like that. Okay, so geo-based ACL is possible. ACL only, restriction only, but geo-based, geographical based it is. Right. And then I can do threat prevention. Maybe if I have some kind of a virus file that is coming into my network, right, that can be done. So threat prevention is possible, right? And a lot of features, guys, a lot of features are possible in firewall, right? I don't remember most of the firewall features that I have got. You can just go and check here and the Bolus and Palo Alto firewall. There you can see what are the other additional features that you have got. So you can do SSL decryption, geo-based CCL, file blocking can be done. Right, there are so many other things. You can do load balancing, policy-based powering. So many things are possible with the firewall. Yeah, again, this point I forgot. User integration, user ID, the user ID integration. Yeah, that's also possible. And VPN, most of the guys are using VPN, right? So VPN is mostly done with the firewall only. If you are using remote access, you are using VPN to connect your office network, I know. So VPN is possible with, VPN is mostly done with firewalls only. Okay. So it's a very interesting course actually. And if you don't want to sign up for the complete course, but still you can go and check some basic previews that we have got. Maybe you can understand a little bit of, you can go to the a store here we have got, and can go to Palo Alto, PCNIC, Palo Alto Firewall. There you can take some preview videos, right? So you can just go and totally 38 hours there. Yeah, you can watch these videos preview, and I think class 4 is what the last video where I've exactly tell you how the firewall looks like and what are the ports it has got, those things and all. Okay, you can check, right? There are basic previews that we have got. You can even check that. Okay, or else if you're using NG app, right, please use it. In NG app, you can take one course, 3 days trial. Okay, and maybe if you're looking for some basic concepts in firewall, you can take 3 days trial access and you can watch that particular topic alone instead of purchasing the whole course. Okay. Yes, please. So we'll finish it here. Thanks for joining the boot camp. I never know this is going to be this successful. Initially, when I started, I was not expecting this many people will come towards the course. But finally, I know that's the behavior of the general audience, right? When the first day, how many people joined. This one around 400 plus we joined, and at the end of the session, we have 75 close to 75. So that's something that generally happens. Not only me, whoever takes the classes, when you do something for free, first day everyone joins it, and slowly they will be dropping. And after 15 days of classes, touching 75 is actually a really good count. Yeah, and also we know that we have some around 930 plus in the group. Again, every day people are leaving. I know that, I don't know. 930 people in the group, in which 400 joined the first day class, and gradually we came till 75. Okay, but it's okay. Anyway, you guys have the lab access also. Please go through the recorded sessions whenever you want. I'll update the recordings. I'll upload the recordings today. Recordings I'll upload next day, tomorrow, and commands will also be updated. So please make use of the course, guys. It's a free content. It's going to be, I don't know whether it's going to be free forever, but it's free right now. So please enroll for the course when it's free itself, right? I believe that you guys have already enrolled. If you have not enrolled it, please enroll when the course is free. Maybe in future I may charge some money for it. Okay, so please do it when it's free. Okay. Yes. So thank you for joining the session, guys. Okay, so of course the certificate I'll share in the group, right? Please stay in the group, and also we are planning to bring one more boot camp later. Okay, so that's going to be completely about cryptography. That will be somewhere around maybe 15 hours of boot camp. That's something that I planned, but that will be in the month of December. I'll update in the group, guys. Please stay in the group. That's a complete boot camp about cryptography, right? If you guys are really interested in learning, you know, encryption, decryption, certificate authorities, again, I'll be the trainer for that also. So we're gonna have some 15 to 20 hours of session for cryptography boot camp that I planned in the month of December. Definitely, I'll include you guys also and notify in the group, so you can share with your friends, and we can also make that boot camp also successful. Okay. So thank you so much, guys. I can see many guys are messaging me. Thank you so much. Okay. So about the certificate, I'll message in the group. Everyone will get a certificate, of course. Whoever joins the session, I'll post in the group. We'll filter based on how many students have attended the session, and we'll give them the certificate. Okay. So thank you so much, guys. Thank you. Bye. Thank you.